So before we start modeling the pipe rack, let us just draw a single, we can say, frame model as to what exactly shall be the dimensions and how we shall be modeling the steel pipe rack. So now, there are different options. One option is that we can have a single column, and from that single column, we can have a beam like this, which we can support that with the help of this kind of bracing arrangement. And on top of that, we can install different, pipes depending on the diameter and the piping engineering requirements. So these kind of that pipe racks, either they can be, we can say, single tier, or what we may have a case where we can have a system like this. Let us say this shall be tier 1 or level 1. The second shall be the level 2. So there shall be, we can say, two different levels on which we may have different kinds of we can say pipe and different diameters and different forces accordingly. So this is a, we can say, single column pipe rack. Second arrangement is that we can have a pipe rack like this, where we have a moment frame after some distance. Let us say, we can say this is a 3D isometric view. So we can have a system like this, and like this. So this distance is usually in the range of, we can say, 6 meter to 7 meter or 7.5 meter also, depending on the requirements. So if it is, let us say, 6 meters, in that case we can have a single beam. But if this distance, let us say, it gets increased to 12 meters in a particular case, so in that case, how we can do the framing is that we can join these beams here. These are the, we can say, different beams, and we can make a truss arrangement here. So this truss arrangement is used whenever we have a large span, so that, because if we are making a single, we can say, beam here from this point to this point, that shall be very heavy if we are designing it for, let us say, 12 meter span. But if we are making a truss arrangement like this, so in that case, the sizing itself reduces and we have a better, we can say, optimized structure. But the only disadvantage for this kind of arrangement is that, let us say, we have a piping coming from here, entering from here. So in that case, this bracing may fall with this particular angle arrangement. So that is the thing we do need to take care while designing these kind of, we can say, long span pipe racks, so that we do need to ensure that there are no as such fouling. That is usually done in a software like SP3D, or there is a software called Navisworks. In that case, basically what happens is that the structural shear arrangement that we are designing in, let us say, Space Gas software or ETABS or SAP 2000 software, so that arrangement is designed in that software itself, and drawings are made. After that, that is exported to SP3D or Navisworks software to have a to detect the clashes. So those clashes are usually with the, we can say, between these pipes, the process pipes, and our structural steel arrangement. So that is coming back to the original topic. So this is our arrangement, that we can have this kind of, we can say, arrangement to support multiple levels of pipe rack. So this is, say, level 1, this is level 2, and this is level 3. Now usually what happens is that the top level is usually reserved for the cable trays. Now cable trays are the ones that are made to transfer the heavy cables from one point to another, because as I said that usually to run a very huge structural steel plant, or we can say industrial process plant, or a chemical manufacturing plant, we do need to transfer the cables also from the transformer area to the process building requirement, process building, where either we are catalyzing, or we are separating, or we are providing a very high volume of current to run the any kind of equipment. So these cables are, let us say, approximately in the range of 50 kg to 30 kg per running meter. These are very heavy cables, and they are also do contribute a lot of weight to these pipe racks here. And that is a standard requirement, that usually it is installed on the top, and on the top here, like at this particular level, we do provide a maintenance platform also along the complete length. So let us say if we are having a cable trace here, and this space here along the complete length, that is usually the maintenance platform, and a vertical ladder is usually provided here so that any maintenance official can go up and we can say maintain the pipe rack if required. So that is the standard arrangement of the pipe rack. So what we shall do is that in our case we shall start making this kind of pipe rack, because that is like quite tough as compared to this, and this is quite easy. We just need to have a single column here, and we can just simply model the pipe rack. In this kind of arrangement we do need to provide this kind of bracing arrangement also at some regular intervals. And what we shall do is that we shall take some spans as, let us say, 6 meters. Two spans we shall take as 6 meters. Third span, we shall take it as 12 meters. And then again, last span, we shall take it as 6 meters. So that we can understand how the pipe racks can be modeled. And we shall be dealing with, we can say, level 1, level 2, and level 3. And the width of the pipe rack, that can be like taken on a, we can say, heavier side only. So we shall assume that this is also approximately 6 meters, so that we can have a very heavy arrangement, and accordingly we can design the structural steel configuration of the pipe rack. So we shall be modeling these four bays only. So in the other direction we do have the 6 meters. So distance between first grade and second grade is 6 meters. And along this direction it is 6, 6, 12, and 6. So we can accordingly model our grids in the ETAP software. We can go to the edit, stories and grid systems. In here we can select the modify and show grid system. We can left click on display grid data spacing. Here we can name it as along the X, we can name it as A, B, C, and D. So we can keep this spacing as 6, 6, 12, and 6. And along the other direction, we can name it as 1 and 2. And we can also keep those distance as 6 meters. So we can left click again on OK. And the storage data, we can assume that the first height here, we can delete this particular story. So we can name it as level 1. This we can name it as level 2. And this we can name it as level 3. So this height we can assume it as 5 meters, and the upper heights that can be assumed as 1.5 and 1.5. So we can again click on refresh view, left click on OK, refresh view, and then again left click on OK. So we can go to the 3D view here. So we do have a rough idea as to how exactly are we trying to make this particular pipe rack arrangement here. Now, in actual, these are like the length is usually in the range of 40 meters or 45 meters. But usually it is a repetitive process only. If you can design this kind of pipe rack, you can design any kind of pipe rack. So we can go to the like draw, beam, column, and brace, and quick draw columns. In here we can go to the plan view here, level 1, and apply and close. We can click on this particular window and left click on add new window to see what exactly are the changes that are happening in the 3D model. So this we can keep it as like 3D model here. While selecting this window here, we can click on all stories and we can add a column here. So let us assume that we do add a heavy column here, let us say in the range of 530 UB and 82. And here you can see the orientation. Now this is the actual question, and this is the mistake that is done by the new engineers also. They are not able to determine what exactly shall be the moment resistant frame and what exactly shall be the shear connection frame. That is the most important lesson that we do need to have while designing these kind of structures. That is the difference between the moment frame and shear frame, and how we can plan the arrangement correctly. So in the few minutes back, I had already said that from this point to this point, it shall be a moment frame, and from this point to this point, it shall be shear frame. So if you wanted to make a moment frame to this point, this orientation is not correct for this particular structural steel column. We do have to rotate this to 90 degrees. So this is the correct orientation of the steel column. That is like this. So we can add all the steel columns here with this particular orientation. So we can add these two columns here also. So now we can see that in the 3D view also, we have modeled all the columns. If required, we can press Ctrl and W, and we can just simply click on the extrude frames option, apply. I think we can press Ctrl, Shift and A. We can check the 3D view here also. We can click on display and undeformed shape. We can close this window here, press Ctrl W again, and under the object assignment we can switch off the sections here, and then press again Ctrl W, and then left click on extrude frames, apply. So here we can see the correct orientation of all the columns here. So here we can see that how this, here we do have a flange, and here also we do have a flange. So we shall be making the moment frame from this point to this point. And at this stage, as per my experience, I can say that these columns are a little bit on the heavier side only, but that is just to show you that how we can optimize the arrangement also at the later stages. So after that, what we need to do is that we can go to the plan view again and click on level 1, switch off the all stories option, click on one story. And here we can go to the draw beam, column and brace. Here, the second step shall be that we do need to draw the moment frames also here. So let us say in our case, moment frame is coming approximately 360 UB 44.7. And before that, we do need to go to the draw and snap options also. In here, it is very important that we can select line ends and midpoint, lines and frame, perpendicular projections and intersections. Select it on apply and close. So that option could have been selected from here also. So we can make a beam from this point to this point. Again, repeat the exercise here also. That is from this point to this point. And from this point to this point. So the moment beam frame beams, these are the frames that shall be responsible for the stability of this pipe rack along the y-axis. So whenever any forces, that is lateral forces, either the earthquake or the wind forces, that shall be traveling along this direction, that shall be balanced by the moment resistant frame here. So here we can see that the first frame has been modeled, and I think we can just simply rotate this model here, and we can delete all of these beams. Just simply select all of these beams, and we can click on, I think there is some error in the modeling, so these kind of things do happen. We just need to import the E2K model again. I think it must be not be happening in your system if you are doing it correctly. So there is some error in the ETAP software itself. Let me just restart it. So if these kind of things to happen, we just need to, click on import an E2K text file. We can save. And from the option, we can just simply, from the same folder itself, from the same file, we can just click on Piperacks E2K again. So that is the text editor file of the, we can say ETAP software. So in majority of the cases, if these kind of errors are there, it too gets resolved. So earlier we were not able to, delete these particular members. So what we can do is that we can just simply go to the 3D view here, rotate the model and delete all of these beams by pressing them, by selecting them. So here we can see that now the beams have been deleted. If required, we can press Ctrl W options on a keyboard, click on extrude frames and apply. So here we can see that now the model is correct. So we can simply go to the level 2 here. So yeah, but before going to level 2, what we can do is that we can just simply draw the correct arrangement at this particular frame, because it shall be repeated on the upper floor itself. So again, we can go to the draw beam column and brace. And in here, we can select, instead of 310 UB32, that is this particular shear connection frame, we can select 360 UB 44.7. So here we have already selected one story option here. So this is also correct here also. And this is the 12 meter that we shall be, optimizing at the later stages. So here also, we can model this particular steel beam from first point to the second point. And after that, we do have a 6 meter span here. So what we need to do here is that we can go to the draw beam column and brace, and we can draw the secondary beams manually, and we can click on quick draw secondary beams. Now the second mistake that engineers do is that they make the frame or secondary beams along the horizontal direction. So in many of the cases I have seen, they draw beams like this. Now this is not incorrect, but that is also not correct, because the thing is that the lateral forces shall be happening along this particular direction. So this is the direction of the piping arrangement. So the steel beam should always be perpendicular to the orientation of the pipe. So the piping is horizontal along this axis, so we cannot have the secondary beams along this particular direction. We do need to have beams along the other direction only. So we can, like make these beams. Now the second question comes as to what exactly should be the spacing between these secondary beams. Now that is also usually given as an input by the piping engineers itself, that their pipe free length can go up to 1.5 meter also, 1.25 meter also, 1 meter also. But in majority of the cases, as per my experience, this spacing is usually kept as 1.5 meters only. So we can add 3 beams here, so that the spacing between first, second, third, and fourth, so that shall be 1.5 meter itself. Here also we can add these secondary beams. We have added 310 UB32 here. Here also we can add secondary beams. Now, if we are having this particular 12 meter, so in here we can add 8 number of beams. So if we add 8 number of beams, our spacing is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it should be 7. If we want to have, we can say 1.5 meter spacing. So if we check the number of spacings here, we do have 1, 2, 3, 4, 5, 6, 7, and 8 number of spacing for 12 meter span. So that gives us approximately 1500 mm spacing between all the beams. So if we see that in the 3D view, this is how our pipe rack is looking now. The next step should be that we do need to add the plan bracing. Now, plan bracing is very much required in this particular cases because we do have a lot of horizontal forces that are coming. As I said that there are like thermal stresses, there are push and pull forces that are acting either along x direction also in many cases y direction also. So we shall be having some that kind of loading also in the load lecture. So as of now, we can start modeling the plan bracing also. So we can click on draw beam column and brace. And in here, instead of the UB, we can select the channel angle section here. So we can proceed with ISA 75 by 75 by 8. And moment releases, it should not be continuous now, it should be pinned in this particular case. So we can add a bracing arrangement like this. Or the second kind of bracing arrangement is that we can also add we do need to click on the draw and snap options here, and in here we do need to select the lines, ends and midpoints and perpendicular projection again. So we can have a plan bracing something like this also, so that whatever lateral forces are coming, it shall be simply be tied to each other. And in many cases, I have seen engineers making the or tying the arrangement like this also. Now, this plan bracing is not at this particular floor level. It is approximately 150 to 200 mm below. So we don't need to worry about applying the loading on these particular steel beams. So that is, one criteria. So after that, we can either proceed with this kind of arrangement, or we can proceed with this kind of arrangement, or we can proceed with this kind of arrangement also. So personally, I do prefer this kind of arrangement for designing the pipe rack plan bracing, because in majority of the cases, this usually simply transfer the load from this particular beam to the column. So my personal preference, as I said, is to make this kind of K bracing arrangement. So we can go to the draw beam column and brace again. We can select pinned option here, and we can draw the plan bracing like this. Ensure that you are snapping this beam to the midpoint itself. Now the problem comes as to how we can, make the plan bracing for 12-meter span. So as I said that for 12-meter span, we do need to have a strong plan bracing also, and we do need to have a strong elevation bracing also. So we shall be, modeling the elevation bracing in a separate lecture. Now this is also like model. Yeah, so now it is okay. Now we do have an option that we can have this kind of, plan bracing along the complete length of the 12-meter span, because these kind of spans becomes very critical uh, when we're talking about the, designing. So either, we can make this kind of arrangement also. So in steel structure, as I said, that more you tie it together, the lighter and the better performance you shall be achieving. We do need to, tie the complete steel structure along the plan also, along the elevation also. So this is a like practical example of how we can model the pipe rack in the, we can say, plan bracing. So now we modeled a particular, we can say, frame in the, we can say, along the level 1. So we can simply select all of the structural steel beams at level 1, and we can simply press Ctrl and R option on a keyboard, and then we can simply replicate to the level 2 and level 3 stories. So we can left click on apply, and now that is done. So whatever modeling we have done, that is now simply replicated to the upper floors also. If required, we can, press Ctrl W option and again left click on extrude frames and see the 3D view as to whether the modeling that is done is correct or not. So here we can see that although it is looking very dense, but it is already very much tied together, and now it was like okay. And one more thing that we do need to, have a concern here, that we do need to provide the correct releases here. So under the plan option, we can click on level 1. We can simply press display and undeformed shape. We can press Ctrl and W option here. And then we can click on object assignment and end releases. Left click on apply. So here we can see that now these secondary beams are having the releases at this point and this point. If we left click here and then again right click, we can see that we do have end releases as end I and end J. Moment M22 and M33 is released at both ends, and torsion is released only at one end. So that is the standard definition of the simply supported beam. Now the next important thing here is that we do need to select all stories here. This particular steel beam and this particular steel beam, that is a beam running along the X direction. They are simply supported beams. They are not moment connected frame beams. So we do need to go to the assign, frame, releases and partial fixity. In here we do need to select torsion M22 and M33 along both the directions. So we can left click on apply and close. So we can check that whether this is replicated on all the floors. Yes, this is replicated on all the floors. So we do have a moment frame along the Y direction and we do have a shear frame along the X direction. So that thing is understood. After that, we do need to add the elevation bracing also here. So although, in many of the cases, I have seen that designer not always add the elevation bracing, but for the optimization and to ensure that there are no as such literal deformations in the wind and while the process is being, done or the liquid is getting transferred in the pipe racks. So what we can do is that we can go to the draw and beam column and brace and again draw beam column and brace. In here, we can select the moment releases as continuous. We can select the frame here as 360 UB 44.7. And we do need to ensure that we have already selected the snapping for the midpoints. So here we already selected line ends and midpoints. So we can just simply, either search for the midpoint here, or we can just simply go to the elevation here and click on elevation number B, apply and close. In here we can select one story only. So we can add a secondary beam here by searching for the midpoint. So here this is the midpoint here. And after that, we can go to the moment releases as spin. And in here, we do need to select the bracing arrangement here. So let us say we proceed with this kind of bracing, that is C-channel bracing, from this point to this point and from this point to this point. So this is one option. That is, we can see that in the 3D view here also. So now we have added the elevation bracing here. Now one more thing here is that the most important portal frame where bracing is required is the long span here, that is a 12-meter span. So we can press Ctrl and R option on a keyboard and select DX as 6 meters because this distance is approximately 6 meters. So left click on apply and close, and we can delete this arrangement. Again, we can select this particular bracing arrangement and again press Ctrl and R option. Select DX. Instead of 6, we can proceed with 12, apply and close. Here you do need to understand that there are no as such releases in this particular beam. Why? Because this is a moment frame. But ultimately, we are trying to control the deflection by providing this particular bracing arrangement. So now we have provided a plan bracing also and elevation bracing for the moment frames, but we have not yet provided the elevation bracing for this long span pipe rack. So what we can do here is that we can go to the elevation and click on elevation number 2 and apply and close. So we can press Control W option again. Instead of invisible, we can select here as visible so that we can simply find out where exactly are the nodes here. So we can go to the draw beam column and brace. In here, we can proceed with the angle sections itself. Let us say we are proceeding 100 by 100 by 8. Momentally, this has to be pinned because ultimately we are tying the upper floors and lower floors. So this is a standard arrangement of the, we can say, tying the 2 or 3 floors together. So we can, draw these beams here. Or what we can do is that to save our time, we can just simply select these two uh, members, press Ctrl and R option, select DX as 1.5 and select number here as 3. So we can left click on apply and close. So now we can see that we have modeled all the vertical members, and after that we can go to the draw beam column and brace. In here we can select, instead of 100 by 100 by 8, yeah, 100 by 100 by 8 is also okay, paint is also okay. So we can model the elevation bracing like this. So that is up to you that how the configuration is required. My personal preferences here always is that I do bracing in this particular direction only. I avoid bracing in like this. Why? Because as I said in the earlier lecture, here is that if I am providing a bracing like this, I am making this as a compression member. But steel is not good in compression. It is very, very good in tension. So to have a further, we can say, optimized structure and to have a lightweight structure with maximum performance, we can make this kind of, we can say, bracket arrangement. So here also we can make this kind of arrangement. We can leave the middle arrangement also. It is not that there has to be bracing in all the possible junctions. Yeah, so this arrangement is also okay. And we can delete these two bracing. And in the center, what we can do is that we can be creative and for 100 by 100 by 8, we can make this kind of arrangement also. So ultimately, we have tied all the possible braces, but some of the boxes, like here, it is empty. Here also it is empty. So that is up to you that how you want to design the elevation bracing for the long span pipe rack. This you can take as an exercise also at your end. Try modeling the different kind of bracing arrangement. Try checking the behavior as to how exactly it behaves. So unless and until you do not make any these kind of 4 to 5 different arrangement, you won't really understand what exactly is the best system for the designing of this kind of arrangement. So we can just simply select all of the additional members that we have modeled, press Ctrl and R option on a keyboard. Instead of X 1.5, we can select DY here as 6, number here as 1, go to the 3D view here and just uh, select the Y option here. Now I think there is some problem here. Okay, so this distance here, it should be -6. Yeah, now it is okay. So we can left click on apply, go to display and undeformed shape, and we can just rotate the view here. We can go to the control and W option on a keyboard. Just click on set to default view options, apply, click on extrude frames here. So now we can see that how we have modeled the like this arrangement here. We can go to the elevation view again, elevation number 2. So this is our long span pipe rack in which we have modeled the elevation bracing, and this is the moment frame here, this one, in which we have already modeled the elevation bracing. Now the modeling part is done. After that, we do need to go to the plan view again, level 1, and apply. Click on display and deform shape. Press Ctrl W option. Just go to the set to default view option. Just we can click on invisible and okay. So the next step should be that we have modeled the pipe rack correctly. We have assigned the releases correctly. We have assigned the members also. Now, what we shall be doing is that we shall be assigning the loading on this particular pipe rack.